Good morning. So today we're going to start with a new chapter called estimation. Now, before we start the class, let us find some terms and ideology. Let's say uh, we want to consider the marks of the statistics marks of whole UTHM, okay? Because statistics subject, not only you, many people are taking. So let's say all the people are taking the same subject, okay? Each and every program taking the same subject. So that whole people who are taking the statistics subject, I'm putting a circle here. Okay, all the people are inside this circle. Okay, all the people inside here. Okay, and I call these all the people who are taking the statistic paper. Okay, I call them as population. Now if I want to find any statistics summary, like a mean, median, mode, and variance, standard deviation, something like that, it would be difficult for me to collect all their marks. Therefore comes the idea of sample. So what you do, you take a small sample of your small portion of your population, like this one. Okay, maybe this is only our program BPA. And then we are going to compute the mean mark for the BPA, and then we can conclude that the mark of all the people taking statistic is somewhere. Let's say we conclude this is your mean mark, mean average. When I plus all of your marks and divide by that number, I will get some mark there. Okay, I will get some mark, maybe 70%. This is only for your BPA, but we can conclude that in estimation, we can estimate that all those who are taking the statistic in the whole UTHM, their marks also surround somewhere around here. Okay, that is much more easier way to estimate. Of course, we cannot compute the the exact value of all of them in the population. We can estimate by using the small portion here. Okay, so what would be the statistic summary that we can estimate here? Okay, for population mean, the notation is this. Standard deviation, the notation is this. Median, notation is this. And mode, let's say mode, normally they don't have much standard notation. Maybe this one can be done. So this is the statistic summary of population, and we call this as parameter. All this mean, standard deviation, median, mode, and whatever data we are getting from the population data, population number, we call them as parameter. For sample, the mean notation is x bar. We have seen this in the previous class. X bar is the mean notation. Mean notation for the sample. Standard deviation notation is S. Median notation for sample is M, and mode we use is V. All these summary statistics is simply known as statistics. Mean, standard deviation, median, mode, we simply call it as statistics. And mean, standard deviation, median, mode for the population, we call it as a parameter. So basically what we are going to do in this chapter, okay, basically we are going to concentrate on mean only. We are going to concentrate on mean only. We are going to estimate, we're going to compute we're going to estimate the mean of population, okay, estimate mean of population by using the mean of by using mean of sample and also standard deviation given some sample size. Okay, given some sample size, given the standard deviation, given the mean of sample, we're going to estimate the mean of population. Okay, we're going to do estimation mean of population. Now go back to here. Okay, very clear. What we're going to do, we're going to calculate the mean standard. Sometimes it is given, sometimes need to calculate the mean standard deviation of this sample sample data here, and then we're going to estimate the mean of population. Why we estimate? Because it is quite hard for us normally to get all the data here. Very hard to get all the data. It is not practical, so we can estimate somewhere around there. We can judge by estimation. Okay, now when I say estimation, okay, when I say estimation, for example, look at this example here. Suppose a random variable x. Now we are looking at sample. Let's say random variable x. Maybe this x is our statistics marks. Maybe this x is our statistics mark. Is normally distributed with unknown population. Okay, so this statistic mark is distributed, normally distributed. As I told you, from here onwards we are going to use normal distribution with unknown population. This is, if you see this sign, this is a mean for population. After the sample has been selected, the numerical value, so now we are computing this. The sample data we are taking is this one. Okay, these are sample data we are taking from here. From here we are taking 25, 30, 29, 33. The point, so when we take this data, we're going to compute this, isn't it? Okay, we're going to compute this to estimate this mean, the bigger mean. Okay, this we can make it, this is smaller mean, this is bigger mean. Because why this is smaller mean? Because it's some from small portion of the sample. If we compute this, we get this one, 29.25, and then we can tell that this mean, the population mean, okay, is somewhere around 29.25. Okay, we can estimate like that. This is called point estimation, one number. But we are not interested in point estimation. Okay, for example, if I if I ask you today what time the sun rise, what time the sun rise, Okay, so let me check what time is the sunrise today. Yeah, sunrise in Malaysia today, I from Google I get 07.06 a.m. Okay, you see this is called this is 7.6006 a.m. is from the Google thing, but sometimes nature, it won't be exactly 7.06. So when somebody asking you what time the sun rise, instead of giving a point estimation, this is called a point estimation, because the Google or any AI technology things, they will just estimate. This is a point estimation. Instead of giving point estimation, it's better for us to give the sunrise maybe in between 7:10 and 7 p.m. Is much more better, isn't it? Which one you guys prefer? This one or this one? I'm sure you guys prefer the second one, the one with the interval. Okay, the one with the interval. Instead of giving one single digit, today the sun will rise exactly at 7.006, or telling that the sun approximately will rise around 0.06. Around means how around? Okay, it's not still not, it's vague, still vague, still not clear. Okay, so for us to give a proper answer for this, I think it should be in interval somewhere here. This is much more clear. Okay, the sun rise in between 7 to 7:10 p.m. Okay, that is nice. Maybe 7:06, 7:07, 7:05. Okay, still in the answer, still it answer the question. Okay, so this is much more better solution. This one better. So instead of giving point estimation for the population here, by using our this one, we consider now interval estimation. This is called interval estimation, where we're going to find some interval for the population mean by using the sample mean. Okay, now basically what we are going to do now is we're going to estimate the mean by giving some interval. Okay, by giving some interval estimation. We're going to find what is this interval, and we call this interval as confident interval. We confidently can tell that the population mean is in between this. We confidently can tell that after some analysis the sunrise will be between 7 and 7:10. So this interval is known as confident interval. Okay, confident interval. Now let us try to do what is the confident interval of this population mean. Okay, let us try example 2. Omitting all the very tedious and critical computation of how am I getting the formula, I'm straight away by using the formula I will teach you now. Okay, I'm going for next page now. In this case, you must understand the for us to estimate, we must make sure the n is greater than the first case. The first case confident interval for single mean, the n is greater than or equal to 0, 30, or this is known. Standard deviation of population is known. Alright. So what is the formula for confidence interval for this one? When n is greater than 0 and the standard deviation of population is known. This is the formula. This is confidence interval. Now let us find, this is a confidence interval. Let us find one by one. According to the question, read the question example 2. Estimate the 95 percentage or 99 and 99 percentage of confidence interval and associated confidence limits for the population mean when I will tell you what is 95 percentage or 99 percentage confidence interval. Before that, let us compute the 95 percentage of confidence interval. Okay, we're going to find 95 percentage confidence interval. Don't worry, I'll explain to you everything. First of all, like this one, mean sample is 950, S is 15, N is your alpha is 1 minus just now 95, isn't it? 95 you write it as 9.05, 9.05. So your alpha value you divide by 2. This is your alpha. Anyway, I'll go one by one. .05. When we get 0.05, you have to understand you split into two. This part and this part. This part 0.025, this part 0.025. This value here is Z alpha over 2. What is this value? According to your table, 0.025. 0.025 is here. 0.96, so this one is 0.96. Z table. Now you have all the parameter here. Substitute inside the formula now. Substitute inside here. When you substitute, okay, I'm going to substitute everything. Yeah? This is how you have to split. We're going to find the interval, isn't it? Normally this is the minus part, you write it here, and the plus part you write it here. This is how you split the interval. So we compute this. You can, this is the confidence interval. You can write it like this, or you can write it like this is your confidence interval. I give you some time to think about it. All right. For continuation, the bit of continuation, we have just now the interval was, this was the interval, isn't it? Still the same question. This was the interval. Okay, the question also asks us to identify what is the confidence limit. The confidence limits is just these numbers. These numbers are the confidence limits. That's all. Just write it here. Confidence limit is 945 1 and 954. These are the confidence limits. Now the explanation, when you ask me what is 95%, 99%, so we are considering here, our computation tells that 95%, we are 95% confident that based on the sample data, just now the x bar, s, n, all this, see, based on the data just now we use, the range of population, the range of population is the just now, the one, the range of population, the range of population is this one. Okay, this is the explanation for the whole thing. We are 95% confident that based on the sample data, the range of population mean is in between this. We are 95% confident means 5% we are not confident. Okay, 95% we may write whatever based on our computation, we can confidently tell, okay, what are the chances that our computation is right. The probability of our computation is right is 0.95. okay, based on this is because this is a computation, mathematical computation. Sometimes it won't tally with the real life situation, like the sunrise. Okay, the sunrise, they can tell you is 7.06, but is it exactly 7.06? Sometimes lower and higher. Okay, so we can tell that based on our computation, 95% there are chances that the population mean is in between this. 5% we may wrong. Okay, 0.05, the probability we may wrong is 5%. Okay, now I'm going to teach another one here, the width of the interval. The width of the interval is, take the highest one minus the width of the interval is 9.8. This is another ideology. Alright, I'm going for, just now is 95, isn't it? Now 99 percentage. Let's go for 99 percentage. For 99 percentage, the x bar is this one. What is alpha 1 minus 0.99? So 0.01. Alpha over 2 is 0.01. This is your z alpha square, alpha over 2. From 0.05, what is your z value? Zero point 0.005. 8 is 6. This one 0.258. Mm-hmm. 0.258. Okay, this is actually the critical value. The critical value. Let me write this stage also. So when you want to use the formula, The answer is either one of them. You can write it like this or you can write it like this, or either one of them. Don't give me two answers, only one is not. For the explanation, how to write? We are 99% confident that based on the sample data, the range of the population mean is in between these two things. Okay, this how we find we estimate the population, the mean of any population based of the sample data. Okay, so it depends on the what do you call the confidence level. So in this case, what would be the width? The width would be 9.5. You can see the higher, see when I want to find the width, how much you get here? You're getting 12.9, isn't it? You see the width is getting higher. 12.9 is higher than the previous one. The previous one is 9.8 only, which means the width is 9.8 is here, means the previous one 9.8. I'm talking about width. This is for 95% is 9.8. For 99%, almost 100%, the width is getting bigger. Can you see the difference? 12.9. For example, just now the sunrise, I give you 7 p.m. to 7 p.m. to 7:10. Maybe you may be the chances for this happen, you maybe be said maybe 80 percentage, something like that. 80 percentage is it chances. What is the width for this one? 10 minutes. But if I give you 7, maybe 6:30 and sunrise, and 8:30, 6:30 to maybe 8, let me reduce this one, maybe 7 to 8, 7 to 8. Then what is the confident level for you to say that the sunrise will be between, for sure, 100 percentage, isn't it? Your confident level is 100 percentage, almost 100 percentage. You may 100% can tell that the sun will rise between 7 to 8. What is the width? 60 minutes, 1 hour. You see this one increasing. As this increase, the width also increase. As the width getting smaller, your confidence level also getting smaller. That's how you see the relationship between the width and your confidence level. Hope you guys understand this. Now for example 3, you go back and try. For the 95 percentage, you write this answer. For 95 percentage, the answer would be 583, 6.47. For 99 percentage, you can assume that the width is getting bigger. The higher the width, the more confident you are to tell that the subpopulation means is in between that. Okay, copy this. You may try at home. Okay, I would like to stop here before I go on with this. Is whatever we did here is n greater or equal to 30, and the next class, which is on a Sunday, we're going to see when n is less than 30. When n less than 30, this is where we're going to use the t table. Remember the t table we used in the previous class? I teach you how to read the table. We are going to use this. When n is greater than 30, we will use a z table. N is less than 30, we use t table. Okay, that is the idea. Now now regarding the test. Okay, regarding the test, you see now we are in week 9, and I already give you the full answer for all the tutorial earlier, so hope you guys did that. Week 9 is in between 5 and 11, 5 and 9. Okay, December. There will be week 10. Week 10 will be 12 to 16. Then week 11, 19 to 23 December. Now we have week 12. Week 12 is in between 26 to 30. Okay, now we are somewhere here. Today is what? We are somewhere here today. Okay, now I would like to have the test on 26. Okay, 26 is Sunday, isn't it? 26 test Sunday. And when is the test? During our class. Okay, so you won't have any reason to tell that you are clashing with other tests. Our test is on Sunday. When is our class on Sunday? 2 to 4 p.m. isn't it? So our test is Sunday 2 to 2 p.m. I give you 1.5 hour to 3 p.m. Okay, this is just information telling you when is the test. How is the test? I will do one video for that. By this week I will do one video. You just don't worry. Okay, don't worry how is the test. I will do one video for the test and assignment. You go through the video and then you any question you can ask me later. Test is on Sunday 2 p.m. to 3:30 p.m. Only 2 questions. And maybe I will use what do you call Google form. Okay, I won't use this for test. I'm not going to use this author. I'm not going to use that. Google form, whereby all the answer you're going to answer in the Google form. Okay, you're going to calculate and answer in the Google form and click submit. That's all. Okay, for the time being, that's all. That's the information I can give regarding the test. Assignment, I will send you a video. Look at the assignment. Assignment is not the due date. I will give end of the week, 14th week or 15th week. During your revision week also you can submit to me the due date. For the time being, concentrate on test. You still have 2 more weeks to go. 2 week plus. You have 2 weeks plus to revision. Okay, 2 weeks plus for your revision. Try to do all these things, and you have to answer 2 questions only. That 2 questions can because test I'm going to test chapter 1. So test is chapter 1, chapter 2, chapter 3, isn't it? Okay, that 2 questions can come out from here or here or here, depends. Okay, so this is the information regarding the test. Please take note. Once I will upload in the group. Okay, don't worry, all the details will be uploaded in the Facebook group and also in WhatsApp group. All right, with that somebody was asking me a question regarding the tree diagram. Okay, they're asking, when I put 0.2 here, how I get 0.8 here, or maybe I put 0.7 here. The question never gives you this probability, but I put 0.3 here. So the idea is the probability for the branches comes out from a same point. This one same point, is it? This is same point, is it? The branch come out. This is same point. The branch coming out from the same point. If you plus this, you must get 1. If you plus this, you must get 1. Let's say that the question gives you here 0.65. They never give you this probability. What would be this probability? 0.35. If you plus here, you get 1. I don't know the student in this tutorial, but next tutorial also I will highlight this. Alright, any question regarding the test? Anything? Any question you have? Anything you can ask me. I give you some time to ask. The assignments, individual assignment, is not a group assignment. Each one of you have to do your own assignment. I will tell you clearly and what is the instruction, what is how to do all this assignment in the video. Okay, I will put it as a tutorial. Today is what, tutorial 7, I guess. So that one would be tutorial 8. No class, just a video, and you can open the video and I will upload the YouTube as soon as possible. Alright, if you don't have any question, don't worry, you can ask me, always can contact me. That's all for today. I'll see you all on Sunday then. Okay, we will continue this exercise. I'll see you on next Sunday, and try to do this, the example 3 here. Okay, all right, with that, take care and stay safe.